In this video, we're going to do a decimal to binary conversion. This is something we'll commonly need to do in subnetting with IPv4 numbers. So what we're going to do is we're going to come up with a number that we can convert from decimal, our normal base 10 system, to binary, a base 2 system. So let's convert 183 to binary. And as you know, binary is all ones and zeros. It's the only way we can represent numbers. And in the binary system, we have a choice of 0 or 1. Those are the only things we can use in order to represent our number. So if we're counting in binary, just as kind of an aside here, we can count from 0, 1. This represents 2. This would be 3. And this is 4. Similar to how we count 1, 2, 3, 4, 5, 6, 7, 8, 9, and then after the 9 we carry it to a 10. Since there's no other digits that we can use, we have to carry it right after we run out of our 1. And then we have to switch to the 1, 0. So these numbers can get very long very quickly because in just a few bits we have to start using multiple digits. So to convert 183 to binary, we need to understand the value of these numbers. If we have a 1 in the first place on the right, its value is 1. And if we have a 1 in the second place, its value is 2. This would equal to 3. And then when we have a 1 in the third place, its value is equal to 4. So we go 1, 2, 4. Now you can see a pattern forming here because this is 1, this is 2, and this is 4. So here's actually the chart that we use to build our numbers in binary. It goes 1, 2, 4, 8, 16, 32, 64, and 128. You're probably noticing this doubles each time it goes up, and it starts at 1 and doubles all the way up to 128. So what we're doing here is we're going to count based on these bits. When a bit is on, we include that number. When a bit is off, we don't include that number. So in order to represent this, I'm going to make this into like a table. And I can use this table to represent this number in its binary form. So in order to do this, if I wanted to go from a decimal number to binary, I could just add up the values that are equal to the ones place. But in this case, what I need to do is I need to take this 183 and I need to take out these values. Now the best way to do this is starting from the far left. So since I know that 128 does fit within 183, I can take that value out. 183 minus 128. And if we do a borrow here, 13 minus 8 is 5, and 7 minus 2 is 5. It leaves me with 55. So when I account for the value of 128 being removed from my 183, now I'm left with 55. So from this 55, does a 64 fit into 55? It does not. So I can't possibly take another 64 out of here, so this value must be a 0. A 32 can come out of 55, so I can take out 32, which leaves me with 23. And I'll account for that value right there. A 16 can come out of 23. I'll just move it over here. And what I'm going to do is the 13 minus 6, leaving me with 7. And I can account for pulling out that 16. Now an 8 doesn't fit into 7, but a 4 does. So I'm down and left with 3. I'll account for my 4. And you can probably see where this is going. A 2 comes out, leaving me with just a 1 left. And a 1 comes out, leaving me with nothing left. So my number 183 in binary is 1011011. 1011011. 111. And that's my answer. That equals 183.